Hello, my fabulous fifth graders. Today's lesson is on subtracting unlike fractions. Our I can statement today is I can use equivalent fractions to add and subtract unlike fractions. Before we get started, let's remember what we learned yesterday. Our question says, Evan walked 3/7 of a mile in the morning and 3/14 of a mile at night. How far did he walk in all? Well, I know that since I have two different denominators, I'm going to have to use equivalent fractions to turn them into like denominators. To do that, I'm going to have to find my least common multiple of 7 and 14. Remember, multiples are the numbers you say when you skip count. Multiples of 7 are 7, 14, 21. Multiples of 14 are 14, 28. Well, I can see already that my least common multiple is going to be 14. My goal now is to turn both fractions into equivalent fractions that have 14 as a denominator. When I look at 3/7, what did I need to do to my 7 to make it a 14? I needed to multiply by 2. I must also do the same thing to my numerator. 3 times 2 is 6. Now I have two fractions that have the same denominator. 6/14, and I'm going to add 3/14. Since I have like denominators, I can simply add my numerators. My answer is 9/14. How can we take what we learned about adding unlike fractions and use it to subtract two fractions with unlike denominators? Let's look at an example. Our model says, Laura has 3/4 yard of ribbon. She uses 1/8 yard of ribbon wrapping a present. How much ribbon does Laura have left? When I know that I'm asking how much she has left, that gives me a clue that I'm looking for a difference. I'm going to start by modeling my problem. Here, I've placed a fraction strip that models one whole. But I know Laura did not start with a whole. She started with 3/4 of a yard. Here I've used 3 1/4 pieces to model Laura's 3/4 yard of ribbon. Next, I've used 1 1/8 fraction strip to model the 1/8 that she has used to wrap her present. And I know that since I am subtracting, I need to find the difference. The difference will be found in the spot here. But how do I know what fraction will name this difference? We must find the least common denominator. To find the least common denominator, we need to find the least common multiple of 4 and 8. 4 and 8. Multiples of 4 are 4, 8, 12, 16. Multiples of 8 are 8, 16, 24. I see that I've got 8 and 16 on both of my lists. My work will be much easier if I use my least common multiple. So 8 is my least common multiple. It's going to become my least common denominator. Now I've replaced my 3 1/4 sized pieces with 1/8 sized pieces. It takes 1, 2, 3, 4, 5, 6 1/8 sized pieces to cover 3/4. So 6 eighths is the equivalent fraction to 3/4. What number did I use to create 6/8 from 3/4? I know that I multiplied my fraction by 2/2 to make 6/8. Now I have 6/8. I'm going to find the difference by subtracting the 1/8. The difference represented here is 1, 2, 3, 4, 5. So 5/8 is my difference. Laura has 5/8 of a yard left. Let's try another example. A female Cuban tree frog can be up to 5/12 of a foot long. A male Cuban tree frog can be up to 1/4 of a foot long. How much longer is the female Cuban tree frog than the male? So we need to find the difference between 5/12 and 1/4. In order to do that, we're going to need to find the least common denominator. Here, they've given us a hint that the least common denominator of 5/12 and 1/4 is 12. Let's use our graphic organizer to help us keep track of our steps. We're going to be subtracting 5/12 and 1/4. Our first step is to rewrite the fractions as equivalent fractions with common denominators. They already gave us the clue that the lowest common denominator was going to be 12. So 5/12. When I check to see this fraction already has 12 as its denominator, so I don't need to change it. 1/4 is a fraction I do need to change. I'll turn it into an equivalent fraction that has 12 as its denominator. Now I have to think to myself, what do I need to do to 4 to turn it into 12? I need to multiply it by 3. I must also do the same thing to my numerator. 1 times 3 is 3. Now I have 5/12 minus 3/12. Since I have common denominators, now I can simply add or subtract the numerators. 5 minus 3 is 2. My answer is 2/12. My next step is to stop and think, does my answer need to be converted to a mixed number? Now let's see. Does 2/12 represent a quantity greater than 1 whole? I know that 2/12 is smaller than a whole, in fact much smaller than a whole, because my numerator is so much smaller than my denominator. My next step is to simplify the fraction if needed. When I look at both 2 and 12, I notice that they are both even. All even numbers have 2 as a factor. So one simple first step, I can divide both my numerator and denominator by 2. When I do that, 2 divided by 2 equals 1, and 12 divided by 2 equals 6. The simplest form of my answer is 1/6. Let's try another example. Jessie finished 1/2 of her homework. Lakshani finished 4/5 of her homework. What fraction more of her homework did Lakshani finish than Jessie? First, I'm going to start by estimating. When I look at the fraction 4/5, and I think about what I know about fractions, I know that 4/5 is very close to 1 whole. When I think about what I know about subtracting 1/2 from 1 whole, I know that my fraction, my answer, should be somewhat close to 1/2. My estimate is 1/2. Now let's solve our problem Again, let's use our graphic organizer to help us keep track of our steps. I know that we are subtracting 4/5 and 1/2. Our first step is to rewrite the fractions as equivalent fractions with common denominators. In order to find what should be our common denominator, we need to look for the least common multiple. We need to find the least common multiple of 5 and 2. Multiples of 5 are 5, 10, 15, 20. Multiples of 2 are 2, 4, 6, 8, 10, 12. From my list of multiples, I can see that my least common multiple is going to be 10. So I need to rewrite these fractions as equivalent fractions with the common denominator of 10. My first thought is to think, what did I do to this 5 to make it a 10? I needed to multiply by 2. I must also do the same thing to my numerator. 4 times 2 is 8. Now I need to do the same thing with a fraction of 1/2. My goal is to create an equivalent fraction with a denominator of 10. What do I need to do to the denominator of 2 to make it a 10? I must multiply it by 5. I must do the same to my numerator. And so now I have 5/10. I can rewrite my problem as 8/10 minus 5/10. Now that my denominators are common, I can simply subtract my numerators. My answer is 3/10. My next step is to stop and think. Does my answer need to be converted to a mixed number? No, it does not. I know that 3/10 does not represent a quantity larger than 1 whole, so it does not need to be converted to a mixed number. Then I need to check, does my answer need to be simplified? Well, since my numerator is 3, 3 is a prime number. It only has 2 factors, 1 and 3. I know 1 is a factor of every number, so that can't count. Now let's try 3. Can I divide 3 evenly into 10? I cannot. Now I know for sure that 3/10 is in its simplest form. So the answer to 4/5 minus 1/2 is 3/10. I had made an estimate that my answer would be close to 1/2. When I think about 3/10, I think, that's pretty close to 1/2. So I know my answer is reasonable. Well, that brings us to the end of today's lesson. Today's lesson was on subtracting unlike fractions. Our I can statement today is,
I can use equivalent fractions to add and subtract unlike fractions.
Go ahead and press pause now if you need more time to add this to your whisk. This is the summarizing question for your whisk. I would like you to explain in complete sentences the steps you can use to find the difference of 3/4 and 1/12. Go ahead and press pause now if you need more time to write this on your whisk. And finally, here is the Q section of your whisk. Here are 3 problems. I'd like you to give it a shot. Use equivalent fractions to find the difference between these unlike fractions. Make sure that your answer is in simplest form. When you've finished, come up with a question of your own for your table partners to solve that shows what you've learned in today's video. I look forward to seeing what you came up with tomorrow in class.